Hi everyone. Now that we have finished the theory, we will start with the programming of the neural network. But first, we need to know how we are going to structure data. We are going to use tensors as modern artificial intelligence libraries like TensorFlow use tensors to organize the data and simplifies the operations between different types of data. For example, if we have a matrix and a vector, we can do a multiplication and we can generalize both of them as a tensor. So it's much simpler than to do the operations. So a tensor is an algebraic entity, and it is used to generalize every type of dimension of data. For example, here we will include the scalars that are real numbers, also the matrix, the 3D matrix, and much dimensions. And the idea of this is that we can create general operations that every of these components can have. So now we will try to get familiar with this tensor. The tensor is a library that I have made to simplify operations in the neural network. So we'll start creating a tensor to get familiar with it. And as you can see, we can create a tensor from an array, a copy of a tensor, or maybe to initialize a tensor randomly or with a rule we want to apply. So I will create an array, for example a matrix that is 2 dimensions. Okay, and we will define it as a new double, and here we'll put, for example, 3 5 sorry 3 5 2, and then 1 2 3. So it will have two rows, that is this row and the second row. So if we want to print it, we will assign the tensor a matrix, and if we want to print it, just put print. Okay, and if we run it, we'll see that we have this tensor. Okay, that is the same but as the matrix, but with a tensor notation. So now we can get, for example, the shape. The shape will be another tensor that in this case is a vector, and we will print it. In this case, it will have the shape is the number of the size of each dimension. So in this case, it will have a 2 at the first dimension, and in the second dimension, it will have a size of 3. Okay, so it will return us a shape of 2 3. So we will see it, and here we can see that this is another tensor with the shape 2 3. More things that we can do. We can also get the rank. Okay, this is an integer and will return us the rank, that in this case is the number of dimensions, so it will return a 2. Okay, this is the more simple thing, that is to know that the how is the vector or the tensor. So now we can know, for example, if it's a vector. Okay, for example, if we want to know that it's a vector, this is not a vector, so it will return false. If we put matrix, it will return true. Okay, now more things we can do with vectors. We have here all the data. Tensors, in this case, I have implemented that they can be converted to JSON file to export it and use it in another time. For example, this is an interesting method because this will upgrade the number of dimensions, so we will create a new dimension here. Okay, it will do this. So if we do this, we will have 3 dimensions. Okay, 3 dimensions. So if we do another time, we'll have 4 dimensions. The inverse operation is to squeeze the tensor. Okay, so if we put here squeeze and we print, it will return this method. The thing that it will do is to reduce the number of dimensions that are not used. And what is not used? That they are size of 1. Okay, so if the dimension has size of 1, we can remove it. So now we'll have the initial tensor. Okay, because we reduce these unused dimensions. Okay, so now what a very important thing is that we can apply a function, okay, to a tensor. For example, we can create the logistic function that we see, okay, and we will get the activation. And this logistic function, we will apply the function and we'll print it. As you can see, now it will return us some values with the activation function applied to whatever structure we have. Another thing we can do is to copy a tensor. Okay, we can divide as a normal way one tensor by the other. If the divisor is not 0, we can use the dot product, but because we have more dimensions, we can specify the dimensions we want to multiply. In a matrix, because there are 2 dimensions, we must use both dimensions and we can't choose. Okay, but here this method lets us to choose the dimension we want to multiply. Also, we can generate a tensor with a certain shape and initializer. And a very important thing is that we can use the method get. This will return as a tensor, and here we will need to put an array. If we put, for example, 0, it will return this tensor, okay, because it's in position 0. Okay, but for example, if we put 0, 1, it will go to position 0 and then to position 1. So it will print a number here. Okay, it will print a number. For example, here we can multiply just scalars. For example, this will print we put tensor tt equals, we put here multiply. And okay, so we need to put this in another line. Perfect. So now here what we are doing is to multiply the number 5 by 3, so it will return us 15. We can do this multiply with a matrix, a 3D matrix, or whatever we want. More things that we have is to reshape okay, sum up is to sum all the values of the tensor. That is simple. Flatten is to put in a vectorized way the whatever structure we have. Okay, so we will put it in a vectorial way. Then a more general thing of the flatten is to reshape. We can specify the dimensions that the multiplication of the dimension must be the same as the multiplication here. Here we have 6 to multiply by 3 dimensions, the shape. So here we'll put, for example, we can put, for example, 6 1, and okay, and we will print it. And as you can see, it created a shape of 6 dimensions, and then it's dimensioned by 1. If we squeeze it, okay, because as you are seeing, one dimension is not really used. We can remove this dimension of each number. So we can put here squeeze, and then dot, sorry, here we need to do the same. And we'll put history dot squeeze, and finally we'll print squeeze. And here you can see that the unused dimension we have removed it. Okay, and all the time we can use shape to know the shape. Okay, so the shape is 6 because it's a vector of size 6. Okay, another thing we can use is to get the transpose of a matrix. This is more different than the regular transpose matrix we know, because, for example, the order we want to know is that every component will have an order of, for example, if it is a 3D matrix, it will have an order of 1 2 3. If it's a matrix, 1 2. So the idea of here of the transpose is we can change the dimensions in another order. Okay, we can put the dimension 2 here, then the first dimension, and the third dimension here, and in a matrix it will be 2 1. That is the only way. Okay, so if we want to do the regular matrix operation, we'll use 2 1 to a matrix, but we can generalize the transpose to every matrix as this. Okay, so we will have, for example, 1 2 3 4, and we can put 3 1 2 4. Okay, so that is how the transpose works. And I think that is almost everything, and in the next videos we will start to implement the neural network in Java with this library. So hope to see you in the next video. Bye.